Hi everyone. We'll see the another problem in the Laplace transform of applications. Determine the current I for t is greater than or equal to 0 if initial current I of 0 is equal to 1 for the circuit shown in figure. So this is your time domain circuit. 10 volts is connected in series with the 4 ohms and 2 Henry. So as a first step, what we have to do, we have to convert this time domain circuit into the S domain. The solution for the S-domain circuit with series initial current in the inductor is shown in the figure. This is the series representation of inductor. Even you can represent the inductor in S-domain in parallel representation also, right? That we'll see later. So series representation of inductor means L will become Ls, 2 will become 2s in series with the independent voltage source 2I0. That is Li0. Ls plus Li0. Ls minus Li0. 2s minus 2I0. I0 value already they have given. Initial current I0 is equal to 1. As per that, we'll get the voltage value as 2 volts. This is the first step. Convert the circuit in time domain to the S domain with the whatever representation, series or parallel representation of the inductor and capacitor. If there is no initial current and initial voltage means simply you'll get the Ls and 1 by Cs, both inductor and capacitors. As a second step, you apply the KVL to this loop. When you apply KVL, 10 by S, this is minus to plus means minus 10 by S plus 4I plus 2S into I. This is 2S into I minus 2 volts. Already it is voltage 2 volts is equal to 0. If I simplify this, I'll get I is equal to 5 plus S by S of S plus 2. As I can use the part as I don't have the direct inverse Laplace transform, I'll split into the two terms by using the partial fraction k1 by s, k2 by s plus 2. Cross multiply, left side you'll have both the denominators will be same, and the left side will have 5 plus s, right side will have k1 into s plus 2 plus k2 into s. If you substitute s is equal to minus 2, you'll get the k2 value, and s is equal to 0 means you'll get the k1 value. By that you'll get the k1 is equal to 5 by 2 and k2 is equal to minus 3 by 2. By substituting this k1 k2 values in this equation, 5 by 2 into 1 by s, 1 by s and minus 3 by 2 into 1 by s plus 2. I have direct inverse Laplace transform for 1 by s and 1 by s plus 2. It's like 1 by s and 1 by s plus a. 1 by s means inverse Laplace transform of 1 by s is nothing but 1. That is 5 by 2 minus 3 by 2 into 1 by s plus a means e power minus at. Here a is nothing but 2. You got the current response I as 5 by 2 minus 3 by 2 into e power minus 2t. In a similar way, the same inductor can be represented in the parallel also. So current inductor is nothing but inductor Ls is in parallel with the current source I0 by S. Inductor L will become Ls, that is 2 will become 2s in parallel with I0 by S. I0 already they have given the value like in the problem statement 1. This will become 1 by S. So now this is your current source. If you apply KVL to this loop, it will become minus 10 by S plus 4 into I plus 2s into I minus I2. That is nothing but I1 minus I2. By simplifying this, if you see this I2, direct inspection method, if you see the I2 is equal to I0 by S. I2 is equal to I0 by S is equal to 1 by S. The inspection method, or just if you observe clearly, outside loop, I2 is equal to 1 by S. I'll substitute that I2 is equal to 1 by S in this equation. I'll have only one unknown parameter, that is I is equal to I1. Here I is equal to I1, right? So I1 is equal to I means I is equal to S plus 4 by S into S plus 2. As I don't have direct inverse Laplace transform to this one, just in a similar way, like this, I'll use the partial fraction and find out the inverse Laplace transform so that you'll get the similar kind of expression even with the parallel representation also. 5 by 2 minus 3 by 2 into e power minus 2t. as a final expression. So in both the cases we got the similar kind of expression. This is series representation, this is parallel representation of the inductor. And one more problem, like a simple problem, convert the current source. All time domain circuit or all time domain analysis can be converted into the S domain by applying this Laplace transform. Convert the current source in figure to a voltage source in S domain. This is your S domain circuit. Directly they have given 20 by S plus 1 is the current source, 4 by S is the parallel impedance, and this is current. How do we convert this current source into the voltage source? Current need to be multiplied with the impedance, and in series with that voltage source will connect the impedance in series. If you multiply both of them, 20 by S plus 1 into 4 by S, that is 80 by S into S plus 1. Voltage source in series with the impedance means 4 by S is in series with the voltage source. This is your current source. In this way we can do any time domain circuit analysis in S domain by applying the Laplace transform. So this is all about the application of Laplace transform in circuit analysis. Thank you all.